Hello there, today we'll be doing linked lists, remove nth node from the end of list. This is our fourth linked list problem. Okay, let's check this out. In this particular problem, we are given, let's say, a couple nodes that are linked to each other, and we're trying to remove the nth node from the end of the list. So let's just do 1, 2, 3, because this is a way to just shorten our problem. And so let's say we're trying to remove the third item, this item, the second item, or the first item. In this particular problem, what we need to do, we need to be able to remove the first item, so we need to create a dummy node. So a dummy node is a node that will point to the head that doesn't, well, that we're using to just keep track of the head. So we have that, and now we can have a slow and fast pointer. So think about this in the opposite order. If you have a slow and fast pointer, right? And if you move this one forward, we'll be one away from the end when this ends. So if we move these forward now, let's say we move this forward again. Once it's fast.next is none, we can set slow to slow.next.next, which is none. We can do the same here and skip the 2, and we can do this here and skip the 1 if it's 3 away. By being 3 away, we're here. By 3 away, I mean. Okay, so anyways, and 2 away is like right here. So we can skip that by moving these forward at that particular time. So, okay, so let's do this problem. It shouldn't be too difficult at all. What we need to do is create a dummy node. We'll call it the dummy head and set it to 0. One thing about it is that we need to set a slow and fast pointer to it, because that's where we'll start. And the next thing we need to do is dummy head dot next is equal to the current head. So while fast, we're gonna set fast equals fast dot next. And what we need to do is move it and n is greater than 0. We need to move n closer and closer to 0. Alright, with that, while fast dot next, that means the next item is not none, we can move slow dot next and fast dot next. And with that, what we're ready to do is slow dot next equals slow dot next. And with that, we can return our answer, which is going to be dummy head dot next, because that's our new dummy. So with that, we have completed the problem, and we are ready to submit our answer. Is there anything else? I don't think so. But it seems that there is a problem here that's happening. Timeline exceeded. Time limit exceeded. That must mean that funny thing is that we didn't type this properly after typing too fast. We just typed in slow.next and fast.next. We have to assign the slow and fast pointer. Okay. And there we go. We got a nice answer. What do you think about this? We switched to slow pointer and fast pointer. That way, I think we have a better way of doing this. Even though it's longer verbiage, it's not that much longer, and I think reading it will give us a better sense of what's going on here, about it being a pointer and everything. So with that, I think we can return this again and get a better answer. Let's submit. And that's it. And I think we got to the core of this particular problem. About how to remove the nth node from the end of the linked list, and there are other ways to do it, but this way I think it's pretty nice, and shows us that we can use in the linked list and operate on it. Well, if you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. Thank you very much. I'll see you in the next one.